In this last chapter, in chapter 10, we are going to cover exception handling. Exception handling is used in almost every language, programming language, and it basically prevents a program from terminating because of an error. And to handle these errors, which are called exceptions, we create try blocks that we put code in that could cause an error. So anytime a user is entering data, or maybe you're reading in data from a file, uh, anytime you are accepting input into your program, there is a potential for an error. Also, if you are doing validation, input validation, you could actually indicate an error condition yourself. So I'll be showing you how to do that too. But anytime your code could flag an error, that code should be in a try block. And that is really all you have to do is use the keyword try, an opening curly brace. Any statement that could cause an error is after the curly brace, and then you'll have a closing curly brace. And so that is how you create a try block. Right below the try block, and this has to be immediately after the closing curly brace, you will create a catch block. And you can have multiple catch blocks. And these are designed to handle the error. And typically, what you do with the catch blocks is you will code a catch block for the different types of exception errors that your program, that could happen in your program based on the data types and the processing that you are doing in your program. Okay, there you'll code up a catch block for every different type of error. And then at the very bottom of the catch blocks, the very last one, you code as a generic catch blocks to handle any other error that could occur. So if you have a try block, you will have one or more catch blocks. And then the finally block is optional. If you have resources that have been opened, such as files, you can close them in the finally block. The catch block is only going to run if there are errors. The finally block will always run. Okay, so even if there's no error, it's still going to run through the finally block. Okay, the try block is required if you're going to do exception handling. And you either need a catch or a finally block. Uh, Almost everyone, I've never ever seen a try block without a catch block, but C# would allow it if you had a finally instead. Um, but I can't imagine ever doing that, because if you have an error, you definitely want to display the error message and handle the error. Um, so typically, if you're going to leave something out, you leave the finally block off. And that's only because there are no resources for you to close, or there's really nothing for you to do in that finally block. So a couple key points to think about when you are programming this type of exception handling. Uh, if any exception occurs inside the try block, the control in the program is going to transfer to the appropriate catch block. And as I mentioned, you will have catch blocks for different types of errors. So it'll go to the appropriate catch block. And for the error handling, typically the error message will be printed out, but you can also print out additional information about the error. The try block always runs, and the finally block always runs, even if there is no exception. Anything in the try, anything in the finally will run. Catch block only runs if there is an exception. And as I mentioned, C# will run with either a finally block or a catch block. But as I said, I've never seen a try block without a catch block. That would not be a standard that I would want you to follow. So standard practice, always follow a try with a catch. And because that it'll run with either a catch or a finally, technically the catch and the finally are optional, because if you have a try block, you can use a finally block, and you could omit your catch blocks. Or if you have a try block, you can do a catch block and you can omit a finally block. How do most people do it? They always do try blocks with catch blocks. Okay. One other thing to note is that you cannot transfer control out of a finally block using a break or a continue or a return or anything like that. And you also can't do breaks, continues, or returns inside a catch block. It won't let you. So how do we implement exception handling? There are a lot of built-in exceptions in C# that it will detect, and it will actually throw an error when it detects that type of exception. And one of them is division by zero. So this little program, simple as it is dividing a number by zero. So we set x 0, we divide 100 by x, and then we are trying to print out the result. And the minute we divide 100 by zero, we get this unhandled exception, attempted to divide by zero. And this is unhandled because we don't have a try or a catch block in here. So to handle this, all we do is we put the division, which is causing the error, we put that into the try block. And then we have a catch block. And the catch block is specifically for dividing by zero. Okay, this is one of the built-in exceptions. It's called divide by zero exception that C# will recognize. And C# is actually throwing this error. Okay, the minute we divide by zero, it's throwing the error. It comes down here and prints out an exception has occurred. And then it will continue on and finish executing your program. So if you look at the output, you can see it goes into the try block, tries to do the arithmetic. It never gets to the line 13. This line will not be executed because it throws an exception. And so the control leaves the try block and moves down into the catch block where it says an exception has occurred. And then we go to the line below the catch block where we print out the result. And you do not have to have a finally block, but if a finally block is present, the try block will execute first. If there is an exception, the correct catch block will execute, and then the finally block will execute. Okay, and then if there is code below the finally block, that code will execute. And so this is an example of how that works. So it was the same example. So we're never going to get to uh, the right line that says this line will not be executed. Okay, we get to the division, it throws the divide by zero exception. So we get into this catch block where it prints out an exception has occurred. And now we do have a finally block. So it goes to the finally block. I'm glad this is over, and that is what prints. And then we're out of the finally block and we execute the remaining code. Catch blocks, try catch blocks are often used with input validation. In fact, there is an exception for entering the wrong data type. In fact, if you're expecting an integer and you enter text, it will throw an exception. And so here is some examples. And for this one, we're having them enter numbers. They're supposed to be greater than 0. So we've got our little validation loop here that is really going to prevent text or anything else from being entered, but we don't have it set up to prevent the entry of a 0. Okay, and so when we come down here, we have a little validation check to see if either of the number is less than or equal to 0. And if number 1 is less than or equal to 0, we are setting it to 1. If number 2 is otherwise, we are setting number 2 equal to 1. And because it's only going to get in here if either number 1 or number 2 is less than or equal to 0. So if it's not number 1, that means it's number 2, and we have to set that to 1. Okay, so we set the numbers so that it can continue on with the arithmetic, but we do throw an exception. So this is an example of us, the developer, throwing an exception instead of C#. And you can throw any kind of built-in exception. This, just throwing new exception, this is kind of the default. Right? So it's not an exception of any particular type. It just means there's a problem. And so that we're sending a message with it. Please enter a number greater than 0. A default of 1 will be used. Okay, so once that gets thrown, it goes to a catch. And it's going to go to this catch. Okay, and the value that we're passing gets stored in message. Okay, and then we are printing that message out. In our little finally block, we are then doing the arithmetic, and we can, because if the number was less than or equal to 0, either number 1 or number 2 was, we set those to a 1 so that we could go ahead and do the division. Okay, and then after the finally block, we just have a little message about having a great day. And here's some sample output. Multiple catch blocks. So quite often, you will code more than one catch block. And the system will pick the correct catch block based on the type of error. If you throw the error, then it's going to look for the type of exception that you created. Otherwise, it's going to look for a catch block that has the kind of exception that C# creates when it automatically throws an error. So in this little section, we've got a couple different exceptions. We've got index out of range exception, which basically happens when you try to index into an array and you are outside the bounds of the array. So if the array has 6 elements in it and you try to index in with a 50, clearly you are nowhere near the array. And that is going to trigger an index out of range exception. Okay? And so when that exception is triggered, it's going to come down to this catch block and display the message. Anytime you divide by 0, um, that will trigger this catch block or this type of exception, which will then come down to this catch block. And what if a different kind of exception is triggered? Well, if it's not index out of range and if it's not divide by 0, any other exception will come through this last generic catch block. So when you are coding multiple catch blocks, you do the more specific ones first, and you keep this generic one for last because this is a catch-all. It'll handle any kind of exception. Okay, and let's take a look at some examples. So this particular example has exactly what I just showed you, divide by 0, index out of range, and a generic exception. And so you can see I do have an integer array, and I've got index, a couple different variables I've declared as index, and I've also got a variable called result. And here in my catch or in my try block, I'm having them enter an index number between 1 and 6. Okay, and to make sure that they're entering a number, I've got them in a while loop. And then because our indexing starts at 0 and not 1, I subtract 1 from the index. Okay, and then I have them enter another index number between 1 and 6, and again, ensuring that they are entering a number, a whole number, and then I subtract 1. And then I go ahead and take the first one divided by the second one and put that into result. So we take our numbers array, we index in and grab a number. We take our numbers array, index in, grab another number, divide them, store the result, and then we print out that information. So what kind of errors can happen? Well, if I put index number 10 and then it's a valid integer, so we are actually going to get down here to this point. It'll subtract 1, so it would be index number 9, but that still isn't in the array. So the minute I tried to index in with that number, I'm going to get an index out of range exception. Okay, so it'll immediately go down here, execute this code, and then it'll go to the finally statement. Okay, and another error that could occur, as you see, the first value here is a 0. So if I gave it a index number of 1, okay, then I am going to have a 0. So if I try to divide by 0, I am going to, we're still going to trigger it on this line. And it'll come down here to divide by 0 exception, and then it'll go into the finally block. So any other error, which I don't really anticipate, but any other kind of error would be caught down here in this generic exception. So the first time I come through, I gave it valid numbers. it did integer division. Okay. And integer division doesn't show a remainder. Okay, so it did the division. It skipped all of the catch blocks because it was valid, and it went through the finally block. Second time I went through, the first index is valid, but the second one is going to be a problem because it is going to retrieve the number 0. Okay, and so we come down here, we end up grabbing 40 for the first number and 0 for the second number. And so then when it comes down to the point where it is trying to divide 40 by 0, that is when divide by 0 exception occurs. And we get the message, and then it goes through the finally block. Okay, and then this third example shows what happens when you go beyond the bounds of the array. Okay, and again, on that step where we're actually indexing in and trying to do the division, that is going to trigger that error. We go through the catch block, which displays this message, and then the finally block. So catching all exceptions. The generic catch block can actually be coded a couple different ways. You can do it like this without any type of exception coded, or you can do this. This is also a generic catch block. And I tend to do this one because quite often I throw my own exceptions, and this allows me to, throw new exception using this as, the exception class that I'm throwing. So that is why I use this one, but you could use either one. Oh, also another reason to use this second version is because it brings in a message as a parameter. So this allows you to pass a message and display it, whereas this one does not. So to throw your own exceptions, we kind of saw an example of that in the first set of coding examples. And basically, all you have to do if you are validating data and there's an error, you use the keyword throw followed by new, and then you have to indicate what kind of exception it is. And in the parentheses, if you want to pass a message, you can. You don't have to. So this is just a divide by 0 exception that I am throwing, and it will go to the catch for divide by 0 exception. And if there is no catch for that, it'll go to the generic catch. So this is an example of throwing exceptions. So this is the same program we were looking at with that little array. But now, after we subtract from our second index, we are specifically checking to see if it is a 0. And if it indexes in and retrieves a 0, that is when we are throwing divide by 0 exception, which is going to come through here. Okay, and then we get, if it isn't a 0, then we kind of continue on our merry way. After it runs through the catch, it goes through the finally. If we are going through the try and there isn't an error condition, we go to the end of the try, it automatically goes through the finally as well. Okay, so this is an example of the output And for this one, we are checking now for a couple different things. We're still checking for that second index to be retrieving the value 0. But we're also going to make sure that the two numbers that we retrieve are not the same. Um, and so we're going to throw a generic exception if they are the same. So we get the two index values so that we can index into numbers. Here we're checking to see if we are retrieving the same number. And if we are throwing a new exception. Okay, so this is where we're using kind of that generic exception instead of a more specific one. And we're still checking for divide by 0. So we've still got the index out of range. We've got the divide by 0. And then we have the new one that we just threw. Now, what else could we do in that program? We could actually have validated those index numbers. And we could have thrown our own index out of range exception rather than having C# do it. Let's see, example 3. So for this one, we are going to calculate the heart rate. And we are validating the age and the resting heart rate in a method. And so age and resting heart rate are getting passed. And then we've got our try block, which is where we are doing our validation. We have a catch block where it's going to catch the exception that we throw, which is just a kind of a generic one. Okay, and then it is going to continue on calculating the target heart rate. And you might wonder, well, how can it do that? Because in our error handling, we are checking the age range. And if the range is not valid, we are setting a default age. And when we throw the exception, we are indicating the age is out of range and a default of 50 is being used. That will allow us to continue and perform the calculation. We're basically doing the same thing for the resting heart rate. If it's less than 20 or greater than 100, it's out of range. So we are setting the resting heart rate at 50. We are throwing a exception message so they know we made that change. That would be visible to the user. And then after the exception is thrown, we come down to the catch where it writes out the message. And then we continue on with calculating the target heart rate and returning that message indicating what their target heart rate is. If there are no exceptions, it's still going to go through this code. Okay? But let's say they enter an age of 30. Okay, well, the age of 30 is fine. Let's say they enter a resting heart rate of 40. Oh, resting heart rate of 40 is fine. So no issues here. We don't run through the catch block, and it still comes through here and calculates their target heart rate. Okay, it returns the message to the main program, and the main program stores the message here and prints it out. Okay, and all the main program is doing is having them enter their age and the resting heart rate. For age, we are ensuring that they did enter an integer, and for resting heart rate, we are doing the same thing. We are ensuring that they entered an integer. Okay, so this little example has the default of 50 for the resting heart rate because they entered a value that was out of range. So they do 29 for their age and a pretty horrible resting heart rate of 200, which would be probably impossible. It would be quite bad. So this is the message that displayed. And then, so it is showing them there was an error, but it does go through and finish calculating the heart rate. So how is this better than not handling an error? So if there's an exception and you don't handle it, the minute the exception occurs, nothing else happens. The program stops. So by handling the exception, at least in this case, we were able to complete the heart rate calculation with the default value and display it. And then this little example just shows the age. Instead of 50, they did 500. So, and their heart rate is, or their resting heart rate is fine. So it prints out the exception information and then it goes on and does the calculation. Now, sometimes if an exception occurs in a method, the method may not want to handle it. So in that case, the method can actually, their catch block can simply throw back to the calling program. So how this looks is we got our method, we have our try block, and in the catch block, instead of, bringing in the message and displaying it, we simply throw, and that throws it back to the calling program. Okay, so here is a little partial example, but I think you'll be able to follow. So we have a little math method up here that brings in two numbers. We are going to see if they are equal, and if they are, we are going to throw a new exception. And that gets thrown to the catch, and all the catch is doing is throwing it back to the program that called it. The program that called it is this main method. This is where it was called. So that is where it's thrown back to, but it has flagged an error. So it's not like it would continue on with any other code in the try block. Because there's an error, it goes immediately to the catch block, and that's what it's printing out. Okay, so to see a full example of that, here we are in our little math method. We're looking to see if the numbers are equal, we're throwing exception. If the second number is equal to 0, we are throwing a divide by 0 exception. Otherwise, we are prompting, what is the first number divided by the second number? And then kind of displaying what the result is. Okay, so if an exception occurs, it gets thrown down to the catch. The catch simply throws. So it gets thrown back to the point it was called from. So here, again, we're dealing with our index numbers. So we've got enter an index number between 1 and 6. So we get those numbers, we subtract 1, and then we pass them along to the math method. If there is an error, okay, any of these error types or even one that we don't expect, it's immediately going to go into this generic catch, which just simply throws it back. So it gets thrown back here. And then this is where it's going to look for those different exception types. If it can't find them, it'll go through the generic. However, we did throw a divide by 0. So if that is what got thrown, it would go through here. Okay? And then it would run through the finally block. So we've looked at some types of built-in exceptions, and there's actually two different types of exceptions. There are application exceptions and there are system exceptions. Application exceptions happen when the developer detects a problem and throws their own exception. So when we code throw new followed by an exception type, that is an application exception because we are throwing it. The other type of exception is a system exception, and that is when the Common Language Runtime, the CLR, which handles our running program, that is when the CLR detects a problem and throws an exception. Okay, so the difference between an application exception and a system exception is that with the system exception, C# is basically detecting it and throwing the error. With an application exception, we are detecting it. Regardless of who detects the exception, all exception classes come from system exception. System exception includes application exception and the system exception classes. The built-in exceptions to C#.NET are part of system exception, and I have included some of the more common exceptions along with a description of what would trigger it. And we are handling the input of bad data through try-parse. But if you didn't use try-parse, you would trigger this type of exception. It's called a format exception. And that happens when C# is expecting one data type and you enter a different data type. Okay, so if we did not use try-parse and force them to enter the correct data type, we would get a format exception. Okay. Other exceptions, index out of range, we've kind of already looked at that. Divide by zero, those are all very common. Overflow exception happens if you are entering a value that is too big for the data type to store. Timeout exception. This sometimes happens when the program is taking too long to perform an operation. If you have an infinite loop, that would trigger that kind of exception, although I think you would figure it out pretty soon and just end the program. But if you did not end the program, you would end up eventually getting this kind of exception. So you can kind of read through the different exceptions and what triggers them. So the reason that developers quite often will perform try-catch is basically so that the program will continue running. That is your goal, that it doesn't just terminate when the exception occurs. And there is quite a bit of information that you can actually display when an exception happens, especially if it is a system exception, because C# automatically generates an exception object. And the exception object has properties that you can display. One of the properties is a message. So you don't even have to craft your own message. You can literally print out the message coming from C#. Other useful information is the message, the source, which is basically the name of the application that caused the error. So that is kind of helpful if you have a lot of C# files in a project, and you have pulled in information and methods from different libraries. Uh, the source may be very useful because then you knowing where exactly the problem happened. And the target site is also useful in debugging because you can get the method that threw the current exception. Okay, so how do we access these properties? When you are catching a system exception, you just follow it with an object name, and then you can use that object name, a dot, followed by the property. So it's the object name dot message, object name dot source, object name dot target site, and you can print that information out. Okay, so here's an example of what that would look like. And I do have some additional examples. So this is an example that we have looked at quite a bit uh, because it's good for the index out of range. And as you can see, not much difference up here in the main method. We are back to just going into and doing that straight division. And then our catch statements are actually what look different here. So for the index out of range exception, I am calling the object E for exception. Okay, and so then it's saying you're indexing beyond the bounds of the array. That's my message. And then I am displaying a system message, the source program, and the source method. Okay, and so I've got e.source, e.target site, and e.message. And then I'm basically doing the same thing for divide by zero and generic. I'm kind of displaying my own message, and then I'm displaying the message source and the target site for each one of those. Okay, and then I've got my little finally block. And so these little output examples are just showing you those messages that are coming from C# and what they look like. So this is my message. Okay, and then this is the system message. So this is the message property. And this is the program the exception comes from. Okay, and that was e.source. And then this is the method that the exception is coming from, and that is e.target site. So it's the target site property, the source property. Okay, and then you can see the same thing here. So that is the end of the chapter. There will be a separate video on your lab assignments.